Okay, now we talk about the shortest job first scheduling. We saw the problem with the FCFS is the convoy effect. That if we got a big process, say we got some process P1, P2, P3, if it is of 100 and this is of 1 processing time I'm talking about, this is say 2, and now because FCFS is a non-preemptive, even this one is also the non-preemptive. Once you give process the CPU, you can't preempt it. Now, if P1 is executed, say 100, this P2 could have completed in just 1 unit of time, but it has to wait for 100 units of time. So it's a sort of convoy effect, and it will increase the average waiting time and turnaround time of whole processes. So we want to actually minimize that. So how we do that is better is if we first load this kind of process, okay, which is the shortest, having the shortest burst time. Then the next one, which has the next shortest, is this 2, and then the 100. So it will dramatically increase our turnaround time, and it will reduce the turnaround time and the average waiting time. Okay, so let's try and see some examples. Now look at this thing. This is the first come first serve example again. This is A is a 10. You do first the A, and you have that the assumption that all processes come simultaneously. Okay, now you gave it the 10, then the B, then C, then D. Okay, and you see the turnaround time which you calculated last time for the Gantt chart and all. You can do that. That's 13.25 and 25, and here it is waiting time. Average waiting time is 8.75. How we do that? Add all them divided by the total number of processes here, 1, 2, 3, 4. So you add all these divided by 4. You add all these divided by 4. That is gonna be the average turnaround time and average waiting time. Now if we do it in a shortest job first manner, now you may see the difference here. We just in the first come first serve we executed the first one which had come, that is the 10, which has a 10 processing time. But now we will try to see which one is the shortest, that is 1. Service time, which has the service time or burst time or whatever you call it, is the 1. Okay, and that's the process B. So we will execute process B, then C, then D, and then A. Like here, we first execute the B, then we execute the C, then we execute the D, and after the D is finished, at this time we execute the A. Okay, so let's try and see what will be the average turnaround time and average waiting time. So here it was 13.25, right? The average turnaround time. But here it is 7.76 only. So it is dropped down. So it is 8.75 waiting time, and here it is 3.26 only. So average waiting time and average turnaround time dramatically drops, because what we do is we load it first the shortest job. But there's the problems in it. I mean, we just see that convoy effect is gone, but still there will be convoy effect if say B was not arrived when the A was there, because it is preemptive non-preemptive scheduling where we can't preempt it. So once it is you get in, you can't do it. Say for example we take the scenario like this, that we are saying now situation is like this. We have the shortest job is the 1, but when we start our execution of our short-term scheduler starts giving from ready queue these processes, at 0 time only the A was present. So that means you have no chance. If you make a Gantt chart out of it, that means at 0 you can only execute A. Okay, now you can't now at time 2, say 0, 1, and 2, at this moment the process B has come, but it is of no use, because A is undergoing execution, so we can't preempt it. Because that's what non-preemptive means, that you can't preempt it. Once you have given some process, you have to finish it as a whole. So the B has to wait, even though it is a SJF, shortest job first, but still you have to wait for the B until the A is finished the whole 10 units of time. Now at that moment, when the 10 units of time, you see B has come at 2 units of time, C has come at 3, so 3 here. At 2, B has come at 3, C has come at 4, D has come. That means when A finishes, at that moment, B, C, D, everybody is there. Now you can choose out of them who is the shortest. Okay, in fact, in this, the B is only the shortest, and C is next shortest, and D is the last one. Okay, so you will go for B. Okay, that means you will start executing B. Okay, with which has a 1 unit of burst time, that is up to 11. Then this is the B. Then you start executing C, which has 3 units of time. 11 plus 3 is 14. And then you execute D, which has 4 units of time, that is up to 18. Okay. Now, if you look at it, it's a kind of same like the first come first serve, is it? And only we have the added logic of SJF here, even though it's working same as FCFS. If you look here, FCFS, the turnaround time is kind of same, 10, 11, 14, 18, 10, 11, 14, 18. So it will have no effect at all, even though we have to go for added overhead of SJF, because SJF, when you try to do a shortest job first, means you are doing some processing in seeing which job is the shortest. But when the processes have not arrived at the same time, so this actually simply fails. Okay, so that's the limitation of this SJF, that processes, you can do it better when the processes have come in the beginning. Okay, that's this point I'm talking about. One major difficulty of SJF is the need to know or estimate the processing time of each job. So this is another, actually, what I was talking about is the other point. I'm saying that they should have arrived in the beginning. Everybody should have been there. Then only then you can calculate which job is shortest, right? Then everybody is there. When it's not there, how you can say someone is short or someone is not, right? Well, this is the one problem. Second problem is how to even calculate that the burst length of a particular process when it is not run. Okay, so you are trying to say this is of 10, this is of 1, but how you know that? That is again a difficulty. That's to know what is the burst length of a particular process unless it has not run previously. So you have seen a log of it, and you have seen, okay, this process run this much of time, and then when it comes next time, you can say, hey, this process is gonna take this much of time. Okay, so for example, you have a print you want to write to the printer, and you know how much time it took, and next time you know, but first time how you know to that particular process have what time. Okay, so that means you can't estimate easily the processing time of each job. Okay, because you are not gonna predict the future. So we have two problems here. One is how to estimate the this burst time of a particular process, even though if you know now you have seen them running, you know them. Now again, if they have not arrived at all arrived simultaneously, you will actually fail the logic of SJF at all. So that is why we should do SJF is a better thing, but we should do it in a preemptive manner. That means if, for example, the 10 has come, the process A has come, which is a 10, the next job B, if it has come and it's having a very less amount of burst time than what's going on, then you should preempt A and load the B. Okay, so that is the preemptive shortest remaining time next. That is the preemptive version of SJF. This is the non-preemptive version. Now we see the non-preemptive version of SJF. Okay.